You who don't know me, my name is Ivan Rochford. Originally, I am from Ireland, but I am based in Scotland now, and I've worked for SKF for the past, I think it's 8 or possibly even 9 years now. I have worked for SKF in the Netherlands, and for a longer period of time, I have been based now in one of the development centers for condition monitoring tools. For those of you who've used condition monitoring before by SKF, you might have heard of the microlog. I work in the development center that produced the microlog historically, and has also produced the tool which I'll present today, which is SKF Insight. The picture here, I mean, for those of you who also know me, it's not unusual to see me in Lycra or out in the hills on a bicycle, so I thought it's a better representation of who I am. I like to cycle, so I think it's more natural to see me in the hills than it is in an office. My responsibility within SKF is to support railway condition monitoring projects in Europe and the Americas. So anything related to business development or project coordination, typically I have an involvement or a hand in it in the company. Just before I jump into them, I've got a couple of slides just covering what is condition monitoring, just from a very basic level. My background is in biomedical engineering. So before I joined SKF, I did work in the area of speech analysis and trying to connect symptoms, what I just there pause, but symptoms of speech with someone's cognitive state. So if someone pauses more, it could be a sign that they might have Alzheimer's, for example. And this was one of the advantages when I joined SKF, is that I can apply the same analytical approach to machines. So if we're getting certain patterns coming from a machine, it can tell us something about the health of the machine. And you'll see that some of the examples that I used to start with about condition monitoring probably do draw from the health industry. So just to the first instance, this is probably something quite alien, but also quite new for everybody. Temperature monitoring. I had this a temperature check like this just yesterday when I visited an office locally in the UK. And I could say that this already is a form of condition monitoring, except here it's not machines, it's people. And what they're measuring is temperature. So there's lots of things that we can measure. In railway, temperature is something that we commonly use to try and infer something about condition. So already this is an easy way of introducing condition monitoring to you. Also, if we think of your heart, that the heart gives out a pulse. It's, if you put your hand on your chest, you can feel a vibration. But also there's electrical signals and there's different things that we can measure, which can also infer something about the health of our heart. And the ECG signal is something that's very familiar for anybody who's taken it. You can, based on the peaks or certain patterns that you see in the ECG signal, will tell us if you've got a healthy heart or not, or if it's operating as expected. And of course, there's different ways of measuring it. There's the quite, I would say, invasive approach, which is the technical ECG, which is on the left-hand side. I'll just change to a laser pointer. So on the left, which is putting on cabled sensors and going to a doctor's clinic. So keep this example in mind. Or you'll see that there's been some innovations more recently. I think this is an Apple Watch. And here they're able to take some kind of a signal based on something that's most people will have, a wristwatch, which is far less invasive and can move with you. So what we're seeing is that technology is evolving, and we're moving away from quite invasive technologies to something that's more integrated. And this is something that SKF has tried to capitalize when it comes to industrial condition monitoring. So there's different approaches traditionally in sensorizing machines so that we can infer something about the condition of the machine. You can use handheld systems. I've talked about the microlog before. This was SKF's flavor of a handheld vibration analysis tool. And this is the equivalent of the ECG that you see on the left. And for a train, it's very difficult to apply handheld portable condition monitoring tools to a train. So what we've done is we've tried to come up with the equivalent of the smart wristwatch, which can allow us to measure something about the condition of the bearings as the train moves and move with the train, and also far less invasive, so we don't have to go to a depot, the equivalent of the doctor's office or the doctor's clinic. So if you consider a railway bogie, there's a lot of parts, rotating parts on that machine, and each of these parts have their own pulse or their own frequency. And you can consider the analogy here is with the heart, but the wheel will have a frequency associated with it and certain patterns that we can analyze to infer something about the condition of those assets. Similarly, the motor, the axle box bearing, the gearbox. All of these will have distinct patterns and distinct signals that we can analyze to see if there's any damage progressing or appearing. And again, these few slides are heavy with analogies, so apologies for that. But if we consider the bogie a bit like an orchestra, what we want to do is we want to try and pick out, for example, the violin or the double bass, or the motor, or the cage of a particular bearing, or the outer raceway or the inner raceway of a bearing, and say that something's wrong with it. So we try to focus in on one particular aspect in a whole vibration signal of noise. So if we go back here, there's a lot of things creating a lot of noise, a lot of patterns, a lot of signals, and we're trying to isolate it and focus in on one particular part and infer something about the condition. And now, the traditional mechanics approach to doing this essentially is vibration monitoring. So you'll see here with a car placing a glass on top of the engine and is trying to infer something about the vibration activity that's coming through and trying to isolate where the vibration is coming from. And similarly, the old mechanics trick of a long screwdriver placed into your ear, being able to try and isolate the source of vibration. So already these are, albeit quite rustic, but these are vibration monitoring techniques. And what SKF essentially has done is formalize this approach and also adopted a more of an engineering mindset to it. So vibration monitoring is nothing new. It's been around for quite some time, and SKF has been one of the key players in the industry for quite some time as well. And we have innovated and we've developed some of the algorithms for it, but vibration monitoring is well established. And if you see on the left here, there's a bearing turning on around. You'll notice if you look at the roller just here, it's rotating at a specific frequency. The inner raceway is rotating at a different frequency. And similarly, if there's a cage here, it'll be rotating at a different frequency again. So you'll see that the train here is moving at a different frequency. And what we do is we use this asynchrony, or these frequencies all being out of step with each other, to try and diagnose if there's anything wrong with the bearing. So if there was a spall on the outer raceway or on the inner raceway, we would start to get a knocking corresponding with one of these frequencies. So I'll use the example here of the inner raceway. It would concur with the rotation that you see of this red dot just here. Or similarly for a roller, if there's a damage on a roller, we'd start to see activities appearing at this particular frequency. So we can start to separate out the activity that we're seeing. And you'll see here, similarly, if we look at the bogie system, traction motor, gearbox, and wheel set, we can apply the same logic of separation of frequencies to try and infer something about the condition of the assets. So when we talk about vibration monitoring, really what we're doing is we're trying to isolate the source and also infer something about the condition of the source, whether it's a large amplitude, low amplitude, and whether the symptoms are indicative of damage being present. This essentially is what vibration monitoring is about. And again, this is just to make the same point. You can consider rotating components quite similar to the hearts that I showed before, that they have a distinct signature, which can really tell us something about the condition of the asset or of the bearing. And what we're trying to do with vibration monitoring is we're trying to catch a fault at such a stage that will allow us to plan maintenance and well in advance of any functional failure. What we see traditionally in the railway industry, this pink line just here, is preventative maintenance. So maintenance is typically done according to the number of kilometers that have been run. And this is easy to handle, but it's also quite conservative. And we know that bearings can run longer. Typically, it depends on application to application, but typically bearings can run longer. And condition monitoring allows us to implement a barrier, which means that if we do have any early failures, that we can catch them using this tool, but also we get to milk more from the bearings. This is important because if we can run the bearings for longer, it also has a significant, let's say, financial impact for the end user or customer. So there's a big value proposition if the bearings can run longer. Also, what we don't want is we don't want to end up at a stage here where we're very close to functional failure. And what you'll see in the railway industry is that typically the normal language that's used when we talk about condition monitoring is temperature. So it's not unusual to hear of trains that have problems being checked or with the temperature gun when they arrive into the depot. For example, I heard of one procedure from one customer. Within 20 minutes of having returned into a depot, they'll check all the bearings with the temperature gun. And this isn't really the best way of checking the condition of the asset. And also, typically, if we do see something hot, it's usually very close to functional failure. And by functional failure, I'm talking about a thermal event or fire, which is not a word you normally want to hear in the railway industry, but really temperature will give us a last indication of something going wrong. Also, what we see in the railway industry is hotbox detection systems. Typically, these are wayside, so this is on the side of the track, and they measure the temperature of the bearings as the train goes past. And again, I've seen instances where these systems have been out by half a degree, so something was at half a degree below an absolute threshold, and then a number of kilometers down the line, that particular axle box actually went on fire. I've seen instances of. So temperature, it can tell us something about the operation of the bearing, so it's part of the picture. But typically, if we're using this for condition monitoring, it gives us a very late warning, whereas vibration will typically be further down the curve, and it allows us time to react. So typically, when we talk about detecting the first instances of damage being present, we're talking about months prior to being in a situation where fire could be a reality. So we're really well in advance of the functional failure stage. Also, SKF, I mean, we are the bearing manufacturer, so it's important just to highlight that we're not just in it for the business of detecting damaged bearings. What we're trying to do is improve the rotation of our components in the field and ensure that we don't have events that happen there. So what we do is we consider condition monitoring as being part of a broader service offering. So today I'll be talking about Insight, which is the picture that you see on the top left. Oops, sorry, I'm going the wrong way. But so we're monitoring the assets, we're looking for symptoms of damage and potentially giving a diagnosis. Once we've done that, then we also have railway field service engineers who can attend the site, remove the damaged asset, and we can also inspect the damaged bearings. Also, you get access to expert application engineering support, so people who know what they're doing can then look to see if there's a trend or pattern emerging in the damages that are appearing in the field. And from that, we can make recommendations about other activities to improve the situation. So we talk about mileage extension projects where we extend the periodicity or the time between maintenance intervals. So in the railway industry, it's very prescribed. The OEMs will say you need to run, for example, 750,000 kilometers. It's usually based on application by application basis, but I'll use 750,000 as an example. But we could consider running for longer, and condition monitoring can be used as a mitigation for the risk of running longer. And at the moment, SKF, as being a bearing OEM, are in a position to underwrite maintenance interval extension projects, obviously subject to review, but condition monitoring is part of that picture. But also, if we're detecting damages in the field, we want to improve the situation as well. So it can also be the impetus to improve the bearing design or improve the mechanical interface. And also, if we're trying something new, for example, the customer's changed to a new design of a bearing, condition monitoring can be an engineering change mitigation. So to try and manage the risk of trying something new in a particular position. And also, some customers typically will only install new bearings, which isn't really getting the maximum value from a bearing. I mean, bearings can be refurbished. SKF regularly refurbishes bearings. We do provide the service. But obviously, trying anything new will carry a risk for a customer or a perceived risk. And condition monitoring also offers the possibility to control that in some way. So we see condition monitoring as not just fault finding, but also something that can integrate into a larger picture of engineering change, of risk management for the customers, and ultimately something that can deliver real value as well when we talk about maintenance interval extension or avoiding unplanned stops. So I've talked a lot around condition monitoring, probably gone off on a few tangents, but the point of today's webinar really was to introduce you to something that I'm quite excited about. I'm excited about it because I've been with this product since its infancy, before it ever had the label Insight. I've worked on this as an application engineer, as a data analyst, and most recently developing the business around this system. When this system was first trialed in Sweden, on a passenger coach, I was the analyst. I was the first person to detect any damages using this system. So genuinely, it's something I am quite passionate about. What you see here, before I move on, it's the title slide, but I think it's worth highlighting. This is the sensor I'll be discussing. And what you'll see, it's a little bit obscured in this photo, is that there's a single bolt mounting it onto the axle box front cover. That's it. That's the extent of what you need to know about the mechanical aspect of Insight. There's nothing else to it. There's no onboard architecture. This sensor is completely autonomous. So when you're fitting it to a train, it's a single bolt fitment, and you don't have to worry about fitting a peripheral antenna or a router or a gateway or cables. So the sensor is completely wireless, completely autonomous, and it mounts super quick. So within 2 minutes, you can have one sensor installed and commissioned on an axle box. But again, I'll go through this as I progress through the slides. The bogie system I showed you earlier with all the hearts considered a lot of different rotating components in the bogie, but for Insight, I'm going to focus in on the axle box bearing, so the wheel set bearing, and also the wheel itself. So Insight is capable of detecting bearing damage of the wheel set, but also it's capable of detecting wheel flats and rolling contact fatigue or wear of the wheels. So when I talk about this solution, this is what I'm focusing in on with Insight. The reason why we're focusing in on particularly the wheel set bearing damages is to try and avoid unplanned stops. So to avoid a situation where we could have a thermal event or a fire. We want to support customers with extending maintenance intervals, so managing the risk with monitoring equipment, and also to optimize inventory. I've seen a number of instances quite recently, possibly exacerbated by the COVID-19 situation, where customers have reached the end of their prescribed maintenance interval, but didn't have the bearing stock available to replace them. So they have to run beyond their maintenance interval because simply there aren't bearings available. So having a condition monitoring system will allow you to plan ahead for having stock available, which, based on the true condition of the assets as well. So if we know that certain parts are starting to enter into a failure mode, that's the impetus or the indication that you need to start planning for securing stock of the bearings. So really, this tool can be used in different ways. I would say the one which is potentially the biggest winner is extending maintenance intervals. I think there's a lot of savings to be had here, but also it's something which carries a lot of engineering control around it. Avoiding unplanned stops, I've seen many customers, particularly in Europe, who've been using Insight, the system I'll be discussing today, to avoid a situation where a train needs to stop on the track, which of course will then cause delays for end users. There's fines, there's fees, there's the cost for rescuing a train. So again, there's a lot of savings associated with avoiding unplanned stops. Now the sensor itself, hopefully this video is coming through okay on the slide. But like I said before, it's a single bolt mounting. You'll see it as it spins. We have it available in M10, M12, and M16 varieties, which should cover the majority of European and certainly in the UK axle box variants. I think 95% of axle boxes globally have M16 brackets. If not, we also have adapter possibilities too. The sensor itself, I mentioned earlier, it is autonomous, so there's no onboard architecture, there's nothing else. What you see is what you get. It's fully integrated solution. It measures vibration. So I mentioned vibration earlier. We've got high quality piezoceramic sensing elements in here. And here, like I said before, we've also got filters which are designed specifically for detecting bearing damages and wheel flat damages. But we also acknowledge that vibration isn't the entire picture. Temperature is also part of the railway world, and it's also part of our condition monitoring system here, where we record temperature every 10 minutes also as an additional mitigation. So for example, if there is a hot box detection, you're able to cross-reference with the Insight system to see what sort of temperature trends you have been receiving. Similarly, if we see an excursion in service, our sensor will immediately transmit an event report to the end user if we see something getting hot. So the idea is that we have vibration, which allows us for well in advance planning and giving you significant warning of anything going wrong. But if for whatever reason something slips through that safety net, we still have temperature as well, it's the last safety net before functional failure. So we have vibration, which should catch the vast majority of damages. In terms of installation, I think this is one of the real advantages of using Insight. Going from the top left in a clockwise manner around, you'll see that from unboxing the sensor, putting the bolt in, installing it onto the axle box, torquing it up, and getting it in position. This takes 1 minute, and there's videos online of people installing the system. It really takes 1 minute to install it to this point. And then the last two steps where you see an iPad here is where we associate the sensor with the position, the train, the location where we've mounted the sensor. So this brings it to about 2 minutes. So really it takes 2 minutes to fit this sensor to a train. And you can imagine that to equip a whole train set, obviously it depends on how many bogies, how many carriages, how big the train is. But I've seen instances where we're able to equip a whole train set in less than an hour. And this is I would say quite revolutionary. If we look at any of the competing systems on the market at the moment, typically they take a lot of time to install. I think the nearest to it takes roughly 20 minutes per sensor. So we're a factor of 10 better than that. And of course, time is money. And so also time in a depot is usually at a premium. Depots are in demand. So being able to instrument a vehicle very quickly and get your entire fleet potentially instrumented in a very short space of time can be a real advantage to Insight. This is more to give you some text to hang on to about what I've already touched on. So in terms of the main features of Insight Rail, it's easy and quick to install. Like I said, so I say 2 minutes, it's probably less than 2 minutes, but 2 minutes is a conservative estimate of how long to install one of these sensors. Fully wireless, no dependency on anything else, so completely autonomous. That's all you need to fit. There's no on-coach installation, and there is a user-friendly interface. You'll see this later. I've got one slide touching on it. And in terms of the main benefits, like I said before, we're trying to avoid unplanned maintenance, optimize maintenance scheduling based on the actual condition of the assets in the field, and also to support maintenance interval extension activities. And in terms of the sensor function itself, this is maybe veering into the more technical aspect of it. It's got a number of routines. So I mentioned temperature. It takes temperature every 10 minutes. And what it also does with vibration is it attempts to take a vibration reading every 90 minutes. And our goal, unlike other systems on the market, is to take 1 to 2 measurements each day. So we'll attempt every 90 minutes until we get what the system considers a good vibration reading, and then it goes into a dormant state. At the end of the day, it will then upload it. So there's a daily upload cycle. If for whatever reason we see something getting hot, which sits up here in this top section, it communicates immediately. So if it exceeds one of the temperature thresholds, communicates immediately. Otherwise, it's constantly in these 10-minute, 90-minute cycles, and then at the end of the communicating everything. Some people might question, why have we adopted this approach? Why not communicate everything as soon as you record it? Part of that is an energy management question. So we want to preserve the power of the sensor. We don't want to drain things too quickly. But also part of it is that we're seeing a problem coming through at the moment of data swamps, so too much data. And we know that 1 measurement, 2 measurements of vibration per day is sufficient because we're able to give such advanced indication of things starting to go wrong. We can manage with 1 to 2 measurements per day. It's not necessary to take vibration readings every 10 minutes. So in terms of the condition monitoring world, Insight will sit somewhere between let's say the traditional route-based handheld monitoring system where you'd take readings every few months on a machine, and an online system which takes measurements every few minutes. So it's somewhere between the two. But nonetheless, we've found that it's well suited, let's say, for the railway application. And we've got a number of examples coming from the field of damages which we have detected. So we know it works, and you'll see later on in the UK we have a 100% true positive damage detection rate. So the system works very well. So why SKF Insight? Why did SKF do this? Why should you be interested in SKF Insight? What's the point? I think normally I would start with these slides, so maybe I've done things in a back to front manner, but in any case, I think it's still interesting to know what the broader picture is. And I've touched on these already to a certain extent. We want to avoid unplanned stops. I touched on thermal events. You'll see a few examples of thermal events in the slides that surround this particular slide. So unplanned stops can be costly. There's one particular example, I think up here, where I know it took a number of weeks to rescue the particular train. And there were also costs associated with the rescue. The repair, I know I've seen examples of coaches which have been in maintenance for months to repair some of the damage caused to cabling and other components underneath the carriage. And obviously, if the train stops on the tracks, you're going to disrupt services, and there are fines associated with disruptions too and delays. So unplanned stops can be costly. And to state the obvious, if you have a fire, it has a direct effect on reliability, availability, and safety of the rolling stock. That's stating the obvious, perhaps. We also talked about extending maintenance intervals. So if we do maintenance less often, it's less cost, and there's a significant saving there to be had. And condition monitoring is one way of managing the risk of running longer than is traditionally prescribed. And also, what I've mentioned before is that the availability of spare parts sometimes force the maintenance interval extension, which is an unexpected risk. And having a system you can quickly fit allows you to quickly mitigate that risk of running longer than intended. So again, like I said over at the example at the bottom, maybe it's not so visible, but this is considering over the 30-year life of a train. The difference between doing 7 maintenance operations or 5 is quite significant. So for a full fleet, the savings for the end user are significant. So condition monitoring has its part to play in bringing about these savings for the end user. I also should say that for SKF bearings, if we're extending beyond, I think it's a 20 or 25% extension of the maintenance interval, we prescribe or mandate the use of condition monitoring as an additional barrier. Talking about barriers, another advantage is that you could equip the vehicles very quickly. So within 2 minutes, you can get one axle box done. In less than an hour, you can get a full train set. So even with traditional wired systems in other industries, there aren't too many similar systems that have this ease of fitment. So it's quite radical, I would say, this particular sensor within the industry. Also, something to consider is that there's minimal engineering change. Having worked on a number of projects with a number of different operators, there's always an engineering change process. And the more components you have, or the more complex the installation, the more effort required to bring about that engineering change and handle the engineering change process. Having a single component with minimal change to the actual asset itself really reduces the effort required from the asset owner or the operator. And yeah, it speeds up the time to install the system and get your approvals in order. And finally, something which is relevant at the moment, the COVID-19 situation. Here, it's the low-touch economy is something which is being spoken about quite a lot. And I've seen some instances with railway customers where they would have people on trains listening for noises, listening for slaps, bangs, rumbles, and then saying, yes, we've got a wheel flat in this position. We think we have a bearing problem in this position. It sounds quite rudimentary, but it is still something that is practiced in the railway industry. But in the current COVID-19 climate, there's less of an appetite to have people sitting on trains doing something because it's deemed not necessarily necessary. And if I look at the UK, the current guidelines from the Office of Road and Rail is that maintenance should only be done when and where it's necessary, which plays quite well for remote condition monitoring. So there's a swing at the moment towards remote condition monitoring rather than having people like technical riders or other people riding on the vehicles. So what we're seeing as well is that there's a growing appetite for remote condition monitoring in the industry. So in terms of how it performs, I think it's worthwhile discussing. There will be some slides in here which maybe are a repetition, but it's just to reinforce the broader picture first before I jump straight in. So it's just to remind you that insight and condition monitoring fits into a broader picture where it's not just detecting damages, it's where we can also provide services for the actual assets in the field. We can support analysis. You get access to application engineering support, and then there's other initiatives which we typically drive, like I mentioned before, mileage extension, refurbishment activities, and engineering change mitigation, to mention a few. So we see condition monitoring as part of a much broader offering that we push. And that's also to say that the condition monitoring aspect of it, Insight, is supported by a team of expert analysts. Within Europe, which is one of the areas that I support, we have 2 teams that are supporting Insight projects. One is based in Aberdeen in the UK, and there these guys have been supporting multiple industries over the years, and over the past, since Insight's been on the market, I should say the past few years, they've developed in the area of railway condition monitoring, which has some peculiarities, so it does require a distinct focus, but they're also experts in condition monitoring. They supported the oil and gas industries. They supported the paper and pulp industries. They've also supported marine. So there's a strong technical foundation here. We know what we're talking about. We're not only bearing experts, we're condition monitoring experts. And what's standing behind their performance are the human beings. So when I talk about the performance of our system and good positive detection rates, this is all credit to the analysts that sit behind the systems that we provide and the ones who do the analysis. So they need to be acknowledged. Before I talk about performance, we need to give a nod to the analysis teams. To give you an example of some of the detections which we've had, now we've got a number of sensors running in the UK right now. I think it's well into the thousands at this stage. And you can see an example of the sort of extremes of damage which we can detect. So here there's a much smaller outer raceway spall. And what you see on the top here is a frequency spectrum. In the frequency spectrum, typically what we look for are evenly spaced spikes, we call them harmonics, which align with the frequency of a particular part in the bearing. So I've talked about separation of frequencies in condition monitoring and parts having different frequencies. In a bearing, the cage, the rollers, the outer raceway, the inner raceway, they will all have distinct frequencies. And if we see these spikes aligning with any of the bearing frequencies, it typically tells us that we're getting knocking or impacting in the bearing. So if I look at this spectrum without seeing the damage on the bottom, I can tell you already that I see an outer raceway spall. And what we're seeing on the bottom here, so small spall through to something more advanced. Really, we can detect a number of different failure modes, I would say. I would say outer raceway damage is typically the most common in railway applications. The other thing to say is that if I look only at the UK, so I am based in the UK, so I have a certain bias. Until now, of the bearings which we have inspected, which is a significant portion of the ones where we've raised alerts, we have a 100% true positive detection rate. We're also in quite a privileged position in the UK in that all our customers use our railway services to dismount the bearings, and we have also been inspecting all bearings when they're returned to Luton, which is a big advantage, I would say, in the UK. So we have full visibility or transparency of the bearing from its birth, let's say, all the way through to its death and its inspection. We follow the sensor, and inside is one way we can also follow the life of the bearing, rather. I talked about a user-friendly interface. These are two screen grabs from the interface. I'm not going to go through it in detail, but what I will say is that the intention of our system is not to say that you have a problem. What we want to do is to tell you that you have to take action in a particular position. So you'll notice that we don't talk about damages, we talk about taking actions or planning. So we will typically respond to a damage detection and raise an alert through the dashboard, which will then be visible here. So you can get a summary in terms of bearings, wheels, and also if there's any issues with our measurement system too. And also you get a list of all the assets which have any actions associated with them. And then if you click in, there's also a fleet view. You could very quickly get an idea of at which positions we're seeing alerts and whether they're the bearing or wheel. And similarly, if you clicked in further, you'd see some of the recommendations or some of the text associated with the alerts. All of this is delivered through a web browser-based dashboard. This is quite new, I should say. So it's only been launched about 2 or 3 weeks ago, this new dashboard. So consider this a sneak preview. Not very many people have seen this new interface. So this is maybe perhaps its world premiere today. If anybody's interested, I can go through in more detail at a later stage, more of the screens here. But essentially what you should see, actionable information, which give you a very clear indication of where the problem or where you need to take action. That's essentially what the dashboard gives you. In terms of references, I've been very Eurocentric until now. Some of the references I have here are from Australia and I think it's Malaysia as well. So we've got one example with Queensland Rail in Australia. And here they were talking about fitting 24 sensors in 40 minutes. Really, they were quite happy with the speed of installation and getting things live on the train. And you'll see October 2018, this solution has been on the market for quite some time, and we've been slowly building up a reputation for ourselves, but also penetrating the markets. Railway is quite conservative, so it has taken a certain amount of time to get to this stage. The other example comes from Kuala Lumpur Airport Express in Malaysia. And there was a I don't know if you know, SKF has a magazine, a technical magazine, and an article was produced about an installation here. The quote, maybe it's quite generic, it's saying that they're quite happy with the system and that they can monitor the train performance. But again, it's another happy customer, and it's another example of an installation of Insight in the field. This is a messy slide. I've borrowed it from another colleague so they can take the blame. But I think it puts across the message quite well. We now have been operating in 25 countries. This was correct as of last year. I think we were even higher than that now. We had a number of sensors go live in the Baltics, I think, last week. So we're already penetrating emerging markets too. And the main message is just that we're present, and we've got a global presence now with this system. If you are interested in this system, maybe it's worthwhile highlighting what sort of path you see in front of you prior to getting the system live. The first step, which maybe I haven't highlighted here, is to contact us. My details are at the end of this presentation, so please contact me if you do have any questions or if you do have any interest in this solution. And the first thing we will do is we'll have an application assessment. So we'll check to see what changes or what type of product we need to provide to you, and also what sort of configuration. So we can configure how often we take measurements, also the frequencies that we do take, and some of the parameters that can be adapted from one application to another. And what we do see in railway is that there's a large difference. There's a large spectrum from suburban applications through to freight transit, through to passenger and high speed. Really, there's a broad spectrum. So we do need to configure some parameters for vibration measurements. But also, we have different diameter mounting bolts for axle box front covers. So we'll just check that the system can fit and if we need to make any changes. So that's the first step. I've got examples of this taking 1 to 2 weeks. So typically this is quite quick, the application assessment. The next thing is to set up the system. So we just configure the fleet into our system and say that we've got X number of trains with Y number of bearing positions. And again, it depends on the number of assets we're trying to equip, but typically this is very quick as well. We've got a number of tools for setting up things at a fleet level now in the background, so it's quite an efficient process to get the system prepared. And finally, just install and commission, and that's it. In 3 steps, it's very easy to go from an inquiry through to having something installed and commissioned. And again, I've got examples of different customers where we've, within the space of 2 to 3 weeks, we've gone from an initial inquiry stage through to starting a small pilot test. So things can progress quite quickly, and I think it's partly in credit to the ease of fitment, but also because the engineering change is quite limited or minimal. So that has been my brief introduction to Insight. Hopefully I didn't bounce around too much or go off on too many tangents. I thought I would also give a quick summary at the end, maybe just to reinforce some of the messages that I did touch on. I did mention before, maybe it's worthwhile just highlighting, I did mention before that I'm based in Scotland. For those of you who've ever been to the Edinburgh area, this bridge is fairly iconic. It's quite an old railway bridge. It's called the Forth Railway Bridge. I think it spans 2 kilometers across a large estuary. So it's a real symbol of railway in Scotland. That's another tangent I've been on. Just to mention that I've focused in this presentation on Insight Rail, which is a wireless system. This has been, I should say, this has been also been fully developed for railway applications, and it's in category 3, shock and vibration tested. It's a rugged system. So consider this a true railway system. It's developed for railway, for axle box monitoring. But we have to acknowledge that axle box isn't the full picture, and that we've got other systems on the bogie. So we've got gearbox, traction motor, also track is part of the picture, and we have developed the IMX Rail, which is more of a traditional wired condition monitoring system to provide monitoring for those components. So depending on your interests, I'm confident that SKF should have a solution for rotating components in railway applications. I won't go to the details about IMX Rail. If you are interested, my details are at the end of this presentation, so please feel free to contact me. And also, just to give a quick summary, is that the onboard system, which I've highlighted today, is just one part of a broader picture where we're combining product and application engineering expert knowledge, I would say, and support, along with condition monitoring expertise to deliver a service to the end user. So really, SKF are in a strong position to support you with rotating components and rotating equipment performance. Finally, if you do need to contact me, These are my contact details. I believe my LinkedIn details are also included in the webinar invitation. So please feel free to reach out to me either by email, by mobile, or on LinkedIn. I'm here to support you. I've also included my colleague for the UK market, Daniele Santamassimo. You can also contact him if you're based in the UK and you've got a specific UK concern. But I do support. I've got a global role, so I'm sure I'll be able to support you if you have any interest in this product. So that was the webinar. So at this point, I would like to open up and see if there's any questions. I'm not sure how we're doing for time. Maybe Ringo, you can give an indication.
No, you're perfect in time, Ivan. You still have 3 minutes left, so we have time for some questions. So please feel free to ask your question in the chat box.
Okay. What I'll do is I'll just stop presenting if I can.